Okay, hi, it's me again, your instructor. So if let's plug in Q here. So this is the general Nernst equation. Let's plug in Q for the Daniell cell, right? This is the Q for the Daniell cell. So the E cell would be, for the Daniell cell, the E naught of the cell is 1.1 volt, right? Minus RT, and the N here is 2 S2. F is a constant, alone activity of zinc 2 plus activity of copper, activity of zinc, activity of copper 2 plus. Now for pure metal, the activity is 1. So the activity of zinc solid is 1 and the activity of copper solid is 1. So you end up having only the activities of the ions, right? So the E cell would be 1.1 minus RT2F ln activity of zinc 2 plus over activity of copper 2 plus. Okay, so if you look at this equation, right? So how can you maximize the E of the cell, right? You can do this by making the activity of the copper 2 plus really big, right? Or large, and making this small, right? So the net reaction of the Daniell cell is that you have the zinc solid plus the copper 2 plus going into zinc 2 plus copper solid, right? So if you want to maximize the reaction to the right, of course you make this amount large and make this amount small. So the driving force is large to the forward directions, right? Okay, so if you want to maximize the E cell when you're not at standard condition, then you have to make this small and make this large, all right? So if you are at standard condition, meaning that the activities of the ions are 1, so 1 over 1, then it's 0, right? If 1 over 1 is 0, then this term will be 0, then you are back at E naught of the cell, which is 1.1. Okay. All right, so next point. What happens if you are at equilibrium? All right? At equilibrium, the Q will reach K, right? And let's look what is this consequence to the Nernst equation. E cell would be 1.1 minus RT over 2F ln K, right? So if you calculate this ln K will give you 1.1 volt, right? So 1.1 volt, 1.1 volt, then the E cell would be 0. Well, it makes sense, right? Because at equilibrium there is no more driving force, net driving force, so the E cell will be 0. When the E cell is 0, then the delta GR of this reaction is also 0, because delta GR is minus NFE of the cell. Okay, so at equilibrium delta GR is 0 and the E cell will also be 0. That's because this value is equal to this value, right? Because E naught of the cell is equal to RT to F on K. In this case, for the Daniell cell, this is 1.1 volt, right?